Today we're going to be looking at lines and angle relationships. This is still pretty much a very introductory type of lesson, looking at how we measure lines or angles and compare them when they were cut by a transversal, parallel lines, perpendicular, lines that are skewed, all very geometric types of vocabulary. So we're going to go through that and give some examples at the beginning before we actually get into the math portion of it. But you're going to see that this is once again going to lay some really good groundwork for what you'll see in more of the advanced classes or advanced lessons that we'll do periodically. So stay with me. I think it'll be very helpful, something that you may want to refer back to as you do move into the more advanced stuff. Otherwise, please make sure that you're subscribing, liking, and commenting and all that. It will definitely help me out. All right, let's look at some of the vocabulary first before we do some of these problems. So parallel lines are lines in a plane that do not intersect. Think of parallel parking. So they'll travel in space next to each other but never actually touch, and the geometric symbol for that is this. So you may see parallel lines A, B, something like that. And always think of this. That helps you out. Perpendicular lines are lines that do intersect to form right angles, and the geometric symbol for that is this. All right, and then one that you don't hear too much, but it is there, is skew lines are lines that lie in different places but are neither parallel or perpendicular. So you may have a line here and then a line here on the same figure. We'll see that in a problem coming up. All right, now what they want us to do is to tell whether the lines below are either parallel, perpendicular, or skew, and we're going to use our geometric symbols that we just had. All right, so we have line DF. You can see we can highlight this. All right, DF being compared to AC. All right, well, these lines, if they continue on, will never touch. All right, so these are parallel lines. We'll do that with two vertical lines like that. Okay. The next one is AD, this is right here, is being compared to BD. All right, now, it's a little tough to see, but we do have this box here that indicates that they form a right angle. So these are actually perpendicular lines. Right, with a shape like this, it's a little tough to see sometimes. And then we have AD again being compared to GE. All right, so these are actually going to be skew because they're not intersecting yet. Now, you may argue that if you continue this line down, that they may cross, but for now, we're just going to do it based off of what we see in the drawing. So these are skew lines, meaning they're not touching. All right, and then we have DG. All right, DG right here, and BE. All right, once again, if you look closely, you can see that these are parallel. All right, we have AB. Being compared to GH. Also skewed lines. And then our last one, we have FH right here, going with GH, and we got that little box being shown, so we know that these are perpendicular lines. All right, let's go over some of the vocabulary for angles as well. I'll be honest, it's probably easier to show you, but I'll still give you the vocabulary definitions here. So adjacent angles, if you know anything about the word adjacent, it usually means next to. All right, keep that in mind. Adjacent angles that have a common vertex, meaning a point where things meet, like the corner of a room, or side, but have no common interior points. Okay, vertical angles, I think of this as they're across the street, they're opposite of one another, are a pair of opposite congruent angles. All right, where a pair of opposite congruent angles are formed. All right, now what they want us to do is to determine all the other angle measures when two parallel lines, so you have this parallel line with this line, all right, parallel, X is parallel to Y, when it's cut by a transversal, which would be this line. So if you ever remember the game from the 80s called Paperboy, where you were like this kid that was on a bike. If you remember the game, this may come back to you, and he traveled down this transversal line, and there was all these houses that he had to throw papers to, and he would get chased by like the Grim Reaper, and he got points for like breaking windows and all that. This always comes to mind when I think of when I would have to do these. But also, if you tell your students, or if you're a student reading this or watching this, think of it like looking at a drone footage of like a neighborhood where most of the streets are parallel to one another, and then there's like a main road going through it. Right, that'll help you out. All right, so we have 120 degrees. We want to find out what A is, right? And once we do that, we can find out what the rest of them are going to be. So we can see that A definitely needs to be smaller than 90 degrees. We know that this entire angle measure has to be 180 degrees. Remember we talked about complementary and supplementary angles? Well, these are supplementary angles. So you'll do 180 minus 120. What's left over is your measure for A. So A is 60 degrees. Okay? Now, with that being said, everything else is easy. It's just a matter of matching. Okay? And this is where our adjacent and vertical angles come into play. So C, well, let's write this in. A is 60 degrees. Okay? C, angle C, is vertical of 120, meaning it's opposite. It's right across the street. But you look, it's the same exact angle measure. So C is going to be 120 degrees. B is vertical to A, so that means that has to be the same, 100 or 60 degrees. And if you take the angle measures of all of these, guess what? It makes 360 degrees. All right? Now, when we get to the bottom part, these lines are parallel, X and Y. Well, if we have 120 degrees here, imagine that you can pick this up and put it right, well, it's going to go right here with D. So D has to be 120 degrees. And it makes sense because it looks like it's the same measure, which it is. All right, G is across the street, so that's going to be 120 degrees, vertical angles, which means E and F have to be 60 degrees. All right, pretty cool in my opinion. All right, now they're going to get really fancy on us, and we're going to try and solve for X, all right? So what makes this difficult is that obviously we don't know what X is, all right, ultimately, but what we do know is that this expression is equal to this expression. All right, so we have 12x plus 3 is equal to 11x plus 9. All right, so let's get the 11x over to the other side. You can go either way here. All right, as we talked about multi-step equations before in another video. So we're going to subtract. This cancels out. We end up with 1x, which is essentially just x, plus 3 equals 9. Now we're not given a choice. We have to get rid of the 3. We subtract from both sides. X equals 6. All right, pretty straightforward. All right, and then the last thing I want to talk about is alternate interior angles, alternate exterior angles, and corresponding angles. So the first one we'll look at is alternate interior angles. So that would be anything inside here because it's interior. Look at our words. So alternate interior angles would be this going along with this. All right, so we can see that the angle measures are the same, but they're in different spots. Another set of alternate interior angles would be this, right? So these are different, but the two arcs, the ones with two arcs, are also alternate interior angles. All right, and then we also have alternate exterior. So we should know that that's on the outside. So let's say that we have, this is going to be everything up here and out here, right? Opposite of interior. So we have this. We go to the opposite side. That's going to go with this. Same angle measures. And then we have the double arcs. That's going to go with this. All right, and then we have corresponding angles, okay? Corresponding angles is more or less what we were just looking at. So corresponding angles would be something like this. All right, I want to use different colors. This red goes along with this here. All right, they're the same. And then we also would have, this goes with this. So more or less they're in the same position, just in a different spot of the street if you think of it in terms of real world applications. And then we would have this goes with this. And then our last one, if you haven't figured it out already, would be this with those. So those are your corresponding angles. So a lot to go over with this. There will be other videos as we progressively get more and more advanced with it. But this is a good resource to start out with.